Hello, this is Goura. Today's our topic is Verilog Syntex. Verilog Syntex flows a specific structure used for modeling digital circuits. The first Verilog syntax is module declaration. A Verilog design or a Verilog code is described within a module. A Verilog code starts with the keyword module and ends with the keyword int modules. The syntax is like that: module, then module name, then port list within parenthesis, then semicolon, then port declaration, then parallel statement, then int module. For example, we write a Verilog code here. The code starts with the keyword module and ends with the keyword int module. We write module, then AND gate as module name, then A, B and Y as ports. Then we declare A and B as input, Y as output. Then we assign A and B into Y, then int module. Second Verilog syntax is data types. Data can be several types like wire, raise, integer. Wire type data represents connection between hardware components. The value is continuously driven by an assignment. Raise type data holds a value and is used in procedural blocks like always blocks. It means raise type data store a value. Integer type data used for storing integer values. For example, we declare x as wire type data, y as raise type data, count as integer type data. Third Verilog syntax is port declaration. Port can be several types like input, output, in-out. For input ports, used to declare input signal, output port used to declare output signal, in-out port used to declare input as well as output ports. It means the in-out ports are bidirectional signals. For this example, A and B is input ports, C is output ports. Fourth Verilog syntax is operators. In previous tutorial, we have seen that operators can be various types. It can be arithmetic or logical or bitwise or relational. Fifth Verilog syntax is assign statement. For continuous statement, the assign statement is used. In this example, we assign in1 and in2 into out. Sixth Verilog syntax is procedural blocks. Procedural blocks are two types. First one is always blocks. Second one is initial blocks. For always block, Verilog uses always blocks to execute a block of statements whenever the condition in its sensitivity list changes. Always block starts with the keyword always, then at the rate of, then sensitivity lists within parentheses, and sequential logic within being and in keywords. Of course, being and in keywords is used for multiple lines. If it is the single line logic, we do not need to use being and int keyword. In this example, process clock is our sensitivity list. Whenever the age of the clock is positive, our sequential logic will execute. Otherwise not. For initial block, executes only once at the start of simulation. Initial block starts with the keyword initial and initialization code within being and int keywords. Of course, the being and int keywords is for multiple lines. If it is a single line code, we do not have to use being and int keywords. Seventh Verilog syntax is instantiation. One module can instantiate another module as a component or as a hardware. In this example, we instantiate AND gate within this module. Then we provide a name for this AND gate is my AND gate. Then ports within parentheses. Then int module. Eighth Verilog syntax is delays. For delays, we using has. In this example, has 5 means 5 time init delay. Ninth Verilog syntax is comments. Verilog supports both single and multi-line comments. For single line comments, we have to use double slash. For multi-line comments, have to use slash star, then multi-line comments, then star slash.